Next topic is stress and strain. When external force applied on an object made of elastic material, they produce change in the shape and size of the material. They produce shape and size means I have that if we have a elastic material and if we apply force on it, as a result shape and the size of the material get changed. Now what is strain and what is stress? Strain, the relative change in the shape or the size of an object to the externally applied force, that is called strain. Means if we are applying force on a body, then change in its length, volume or the surface is occurring, so that is called strain. And the stress is the internal force associated with the strain. Now suppose if I apply force on a body along its length, but its length do not change, so in that case stress is more, so that's why it's not occurring, no change in the length is occurring. So strain produces very less because the change is quite small as compared to the force applied, so strain is also very less, where the stress is force per unit area associated with the strain. Hooke's law states that stress is directly proportional to the strain, that if strain is more then stress is more, if strain is less then stress is less. So it states that stress is, just a minute, it states that stress is directly proportional to the strain. This is according to the Hooke's law. More the strain, more the stress, less the strain, less the stress. Now there are different type of the stress like normal stress, shear stress, and normal stress is of further types tensile and the compressive. Now what's the meaning of a normal? Suppose if I have a length, if I'm applying, having a length, if I apply force on it, so I'm applying force normally to it, so it is a normal stress. But if I displace it through an angle, like if I apply force in such a way that it displays through some angle, that is called shear stress. This is the stretching and this is the compressive. Now next, stress is, so indirectly we can say it's force per unit area because it's equals to just the pressure, and strain, it's actually changing the configuration upon the original configuration. Next we have three type of modulus. Young modulus, that is called normal stress upon longitudinal strain. Longitudinal strain means three type of strains are there basically. Longitudinal, that is change in length upon volume. Surface, change in area per unit volume, area upon volume, that is change in volume divided by original volume. So young modulus, which is given by y, it is equals to the normal stress by the longitudinal strain. Bulk modulus, that is also equals to the normal stress by the, bulk means we are dealing with the volume, not the one or the second dimension, we are taking the volume here because we are considering bulk. And it is inversely proportional to compressibility, means more the bulk modulus, less is the compressibility. Shear modulus, modulus of rigidity, that is equals to G, it is equals to shear stress upon shearing strain. Shear stress upon the shearing strain. Next we have is the Poisson ratio. Poisson ratio is formula is shear stress upon longitudinal strain. Further we have a relationship between the Young's modulus, bulk modulus and modulus of rigidity, and last one is Poisson ratio. This all are the relations between them. This is the Young's, bulk, and this is the Poisson's ratio. So these are the relation between the different quantities. Next we have Hooke's law, that we already discussed, that stress is directly proportional to strain. So this is a constant that is called modulus of elasticity, Elasticity, plasticity, that we have done. What's its application? By knowing the elasticity of a material, we can design the beam for the bridges. Suppose if I have to make a bridge, then what type of beam I will choose so that it will not get loosened or it will not get so tight that it not allow the little bit elasticity to the material. So if we want to design such type of material, we should know the elasticity of the material. So that's why the knowledge of the elasticity and all things is required before designing any kind of the material or the building in which the beams and other things are required which have some elasticity.